So one of the dependencies that we added during the Spring Initializer step is Spring JPA. Spring JPA will allow us to use a class to represent the structure of a table in our database. The Postgres database that we created and connected to our Springboot application will be where our tables will be stored. So like I said before, an entity represents a table in a relational database, and each entity instance corresponds to a row in that table. So one of the entities that we'll be creating is a user entity. It is going to be a table that represents the users that will be using our application. So as you can see here on the screen, we're going to need a couple of annotations. We're going to need the @entity annotation to let Spring Boot know that we're going to be creating a entity utilizing this class, right? This user class. And inside of this user class, we're going to define some properties that will define the columns in our table. Then there's the @table annotation, which will allow us to change some of the properties of our table. For instance, the name of our table, right? So in this case, I want to change the name to users instead of user, right? Plural. Now going into the class, like I said, each property is a specific column in the table. So I have an ID, I have a first name, and I have a last name. And on the right, you can see the corresponding table that represents the properties that are defined in the entity itself. So the table has a column of ID, first name, and last name, and each instance of that class, right, represents a row. So I have the first row, which is going to be an ID of 1, right? I'm using the @generated value @ID annotation, which will generate an ID for us, and it will increment it by 1 each time we add an additional row to the table. So the first row is going to be an ID of 1, define a first name, define a last name, then a second row, which is going to have an ID of 2. As you guys can see, it increases by 1, and the first name is going to be legendary, and the last name is going to be fewer. So let me give you a professional definition of so let me give you a professional definition of an entity. Entities are the persistent objects stored as a record in the database. So each instance of the entity class will be considered a row in the table it is representing. So just like I just went over in this example, each instance of an entity class will be considered a row in a table that it is representing. And in this case, it is representing the users table. All right, so here I am back in the application. And the first thing that I want to do is I want to go ahead, right click here, and create a new package called entity. Because honestly, I just want to split it up. I want to clean this up to make sure that everything is in its proper place when it comes to models. So we may have, as you can see, DTOs, and then we can actually have entities. So I'm going to create another package called DTO. And what I'm going to do is I'm going to place all my DTOs into that package. Now, you don't have to do this, but just to make it a little bit more structured, I would recommend it. So let me go ahead and refactor that. So wherever this is imported, it's just going to make sure that it changes to the new placement of where the file is going to be. So I'm going to press refactor here. Granted, I don't think this is being utilized anywhere yet, but just in case. And then here I have my DTOs in the DTO folder, and then I'm going to create my entities into this entity folder. So I'm going to right click here again and press new Kotlin class. And the first Kotlin class I want to create an entity is going to be called user, because we're going to create a user entity which will represent the table in our Postgres DB. Let's start defining the annotations, right? We will use the entity annotation to let Springboot know that it is an entity. So @entity. All right, press enter, and now we have that. So it's coming from the Jakarta persistence.entity. Remember, we specified a DDL auto in our properties file to create tables when the application start, right? Remember, it's going to drop tables and then recreate the tables, right? Just based on the specification that we added in our application.properties. So if I go here, we specify the DDL-auto as creates. So it's going to create the tables based on the entities that we define in the database that we connected to, right? Because we defined the data source URL as this Postgres instance, and this funds application is our database. So it's going to create the tables in this funds app database. So back to users. The second annotation I'm going to use is @table. And it's also from Jakarta dot persistence, open that up, and I want to define the name to be equal to users, right? So instead of it just being user, right, I want to define the table name to be users. So that's really the two basic annotations that we'll need. Let's actually start defining the columns for our table, right? Let's define the properties within this class, but these are going to be properties that are going to help define the table columns. So the first thing I want to create is the primary key, right? And that's going to be the ID, right? So it's going to be for ID. It's going to be of type long. We got to set it up to nullable, right? But we're going to leave it in the hands of our database, right? And how we're going to do that? Well, we're going to use at ID, right? That's going to be the first annotation, and it's going to go together with the at generated value, right? And these go together, right? The generated value annotation is used in conjunction with the ID annotation when it comes to creating a primary key field on an entity. So by default, it will fall back to the ID generation method based on the dialect that we're using. So in this case, we're using a PostgreSDB dialect. So in the case of PostgreSDB, it will auto increment. So just like how we saw in the diagram where the first row is going to be of ID 1, then the second row is going to be of ID 2. That's what's going to happen with this at generated value by default, right? It's going to generate an ID, and because we are using a Postgres dialect, it's going to auto increment the ID. Now, if you want it to be different, then you could change the configurations in your database, or you can use a different strategy. So by opening up some parentheses and doing strategy is equal to generation type, you can see that there's different generation types. So if you want UUID, if you want a sequence, if you want an identity, because I believe identity matches the configurations of your database. So if you change the configurations from your database, then you can use the identity. There are different options for generating the ID, but in this case, I'm just going to use auto because by default is going to be of generation type auto, and I believe that was the first option here, but I don't have to specify because that is the default value for at generated value annotation. So I'm just going to leave it without the strategy, and that's just going to auto increment my ID by 1. And the rest should be pretty self-explanatory. If anything, I'm going to copy and paste it in just to save some time. So next couple, and I'm going to go over it, is going to be first name, right? I want to make sure that the user has a first name, the user has a last name, an email, store the password. And if you want to, you can also just create another entity class of profile and then associate it back, create a one-to-one connection between user and profile. But just in the product of time, I just put it all in here. But usually it would just be what you need specifically for a user, especially when it comes to authentication within the users table, and then you associate the user's information into another table. But it really is up to how you want to set it up. In this case, I'm just going to place it all in one table when it comes to user. But I just want to give you guys that knowledge of how other people may set it up. But yeah, so there's going to be first name, last name, email, password. Email and password is going to be utilized for logging in, and by default, it's going to be an empty string. Then the next thing is going to be var age, and that's going to be of type int, and I'm going to make that equal to a default value of 0. And don't worry, we're not going to keep it as that. We're going to have some validation being done here just to make sure that when someone does try to insert into this table, that is not going to be with these values. Like this is not good. So there's going to be some validation being done just like how it's being done with the DTOs. But I just want to define the properties first. So the next property that I want to define is default account ID, and that is going to be long, and it's going to be the default value of null, and I forgot to put the equal in between, and this is just going to be the default account for deposits or sending money. So by default, when a user signs up for an account, a savings account will be created for them, and that will be considered the default account. If they want to change it, they can, but when they sign up, an account is already created for them, and it will be provided as the default account, and their ID will be stored here, and it's going to be associated back to the user. So this is important because when someone needs to deposit or send money, right, this will be the default account that will be utilized, right? If you want to change it to another account, maybe you have a checking or another savings, just for deposits or just for people sending money to you, then you can change the ID of the account as long as it's associated to you. But by default is going to be, your default account here. So the next two properties I'm going to define are timestamps. Usually when you input information to a table, you want to know when it was created or when it was updated. Especially when it comes to a user, you want to know when the user was created or maybe the last time a user changed information regarding their account. So I'm going to create two timestamps for that to help show when it was created and the last time it was updated. So I'm going to do val created at, and I'm doing val because I don't want it to change after it was created. So I'm going to do date, and it's going to be nullable at first, and we're going to use annotation that is going to automatically insert the information into this property. And I got to make sure to import date really quick from the Java util, and I'm going to use the at creation timestamp, and this is going to insert that date when this row or when an instance of this user is being stored into our table. And then the next one would be using the at update timestamp, right? And this will be stored in the updated, and it's going to be a var here because this will change, right? If it ever changes, right? If ever any of the properties changes here, it's going to update this timestamp, and I'm going to call this update at, or you could even call it modified at. It's up to you. But I'm going to do date. It's going to be no, but not really, because once this is created, then it's going to automatically inject the timestamp into it, right? So on creation, that's considered an update. So it's going to place a date into the created at, and it's also going to place a date into the updated at. But if we were to change anything like first name, email, or anything like that, then the only thing that would change after that is the updated at. So those are the two properties I'm going to create for that. And then later on, when we create the account entity, we're going to have to come back and add another property to define the relationship between a user and an account, but I'll come back for that. Now, very quickly, I want to go over the validation for each of these fields because honestly, we don't want to just have these default values of just like an empty string and um, the age of just being 0, right? We want to provide or make sure that the user provides the correct values. Maybe somehow it got past the DTOs, right? The validation of the DTO. We want to make sure we even have validation on the insertion or even the ability to update on a specific row or adding an additional row to the user table, right? So I'm going to ask for validation here. And just like with the others, I'm not going to write it one by one just to save some time. I'm going to copy it. So the first one I want to do is not blank and not empty. We utilize that during the DTO uh, just to make sure that a user doesn't try to get fancy and try to add additional space afterwards to make it look like it's the proper length. We can use the not blank to help with that, and also not empty to make sure that it's not null, right? And that there's actually values within it. So let me just import these two. Also from Jakarta. And we're good to go. And I'm going to also do the same thing for the other strings, right? So we just got to make sure that the messaging makes sense for each property, but it's going to be the same logic, right? We want to make sure that there's a value inside of first name and there's a value within last name, email, password, etc. So that is, and then for password, I'm going to go ahead and place that. And for the age, that's going to be the main difference, right? We know we want to make sure that a user signing up for our application got to be at least 16 years old. So the minimum is going to be 16. And before we even defined a maximum, so let me do at max, and I'm going to define that. And I totally forgot what I placed as max for the sign up DTO. So let me go back for that. It was 135. And honestly, let me just take all of this, right? Let me just make sure that they receive the proper messaging as well. Of like, you have to be at least 16. And for the sign-up DTO, it was also 135, but you got to be between the ages of 16 and 135 as the message. So that applies here as well. And for default account ID, I don't really have to worry too much about that because that's going to be inserted by us. And then the timestamp is going to be generated by the annotation in itself. So we're good on that end. All right, so the next entity that we'll be creating is the transaction entity. And here on the screen, I have a smaller version of the entity. There are more properties that we'll need to define, but these are the main ones that we'll need, and I'm going to go over it really quick. So this will represent the transaction table, this entity. Every funds transaction that comes through the application successfully will be stored. And to start off with the ID, it's the same concept, right? We'll need an ID annotation and a generated value annotation to create an incrementable ID that will serve as the primary key, meaning it will be the unique identifier for each record. Next is the amount, which I'll set to be the minimum value of 0. We do not want negative values. That will cause problems, big ones. The next thing we'll need is the user ID, which will represent the user ID of the transaction owner. Who is interacting with a specific account, who is trying to make a transaction. It is important to save that information. So it is a mandatory value. And we got to make sure to do some validation internally to make sure that that user ID belongs to an existing user. So that will be done on the service side. Remember the diagram where there's controller, service, and repository? Before we save the information, we got to make sure that on the service side, we logically check that this user ID belongs to an existing user. And to add another layer of protection, we'll be retrieving the user ID from the JWT token. So we'll make sure to extract the value from a valid JWT token and store it into our database. And the next value that we're going to be storing is the transaction type. Transaction type is required because it will determine what type of transaction is taking place. It can also be used for filters, right? What if we want to just receive or see deposit transactions or withdrawal transactions? We'll be able to create a filter specifically based on the transaction type. So we'll be creating an enum class to define different types of transactions and storing the transaction type exactly how it is into the table. And you can see a little example of it on the side, right? We have ID, we have the amount, and we have the user ID, right? User 1 is making a deposit of 20. Then the next row is going to be incremented, the ID is incremented, and we see that user 1 needs to withdraw an amount of 10, right? And we can see that he has enough money, or he or she has enough money to withdraw $10 because initially user 1 already deposited 20. Now, if they try to withdraw 21, now causing a problem. They'll be shown a error, right? Of, you don't have enough funds. But in this case, the user does have enough money because they already deposited a certain amount. So that'll be the logic for that, right? Successful transactions. And if you want to store bad transactions as well, just for security purposes, you can, or just to provide a flag of how many failed transactions occurred, that can be done as well. But just for for time, right? It's just going to be successful transactions. So we're going to create a transaction type enum. And within this enum, we're going to have 4 types of transactions. We're going to have deposit, withdraw, transfer, and send. So now when a user creates a transaction, we'll be able to save based on the transaction type. So whether it's deposit, withdraw, transfer, send, that value will be saved in our transaction entity. And this is important because we don't want to have the ability to have a random string being saved. We want to make sure that it is a transaction that we know and that we created and that we actually have in our application. And in the future, if we want to add a different transaction type, then we go ahead and add it to the enum, right? But we shouldn't have a free string text for a specific transaction type. We'll have an enum that has the different type of transaction types that we can grab the value from the enum and store it into our database. So in this entity folder, what I'm going to do is I'm going to create a new Kotlin class called transaction, and we begin the process of creating the entity. So first things first, let me define the annotation. So at entity, press enter from Jakarta, and then it's going to be at table. And I'm going to provide a name of transactions for the table, transactions. And we've got S here, transactions. And I'm going to define one more annotation, and that's going to be JSON include. And that's going to be JSON include dot include dot non-null. Now, what does this mean? Well, when we retrieve the transactions, we want to make sure to ignore the null columns. And we're going to create some properties that may be null because it may not have been needed for a specific transaction. So that's the reason why I'm doing this rule of JSON include to only include non-null values. We don't want null values in our transaction when we're retrieving it. We want to make sure that we only display values that has a value, right? Properties that have a value. So I'm adding this annotation for that. So let me go ahead and start creating these properties. Let me do @id because I'm going to start the process of creating this primary key for the table. This is going to be the unique identifier for each individual row in our transactions table. And I'm going to leave the default value for generated value, meaning it's going to increment the ID by 1 for each row. And it's going to be var of type ID. It's going to be long. And initially it's going to be null, right? But this is going to be handled already. So it's going to automatically generate the ID for us and insert it. So we don't have to worry about that. The next property I'm going to define is the amount, right? I'm going to make the minimum value, like the user has to have a minimum value of 0. So let me actually import that really quick. And it's going to have to be minimum value of 0. If you want to do 0.01, a penny at least, then you could, but I'll just keep it at 0. I just don't want any negative values because that will cause problems. And it's going to be a double, and the default value is going to be 0.0, right? Then the next value I'm going to define is the user ID, right? This is going to be associated to a specific user, and we're going to do some validation prior to make sure that the user actually exists, but this is going to be the user ID of who's making the transaction, right? So whether it's deposit, whether it's withdrawal, we want to make sure that we save that information. Initially, I made the mistake of attempting to use email, but little did I know that email could be changed, right? A person could, deactivate an email and try to change the email to another email. Maybe they had a Yahoo and they want to change to a Gmail. That can be possible, and then that will create problems for our transactions because now we don't know who to associate the transaction to. So user ID is always going to be associated to a specific user, so it's better to use that than any other property. And we know that the user ID is going to be stored later on in a token, so this will always be attached to a valid user. Now, the two properties here that may be null and is the reason why I included this @JSON include annotation to ignore them is the from account ID and to account ID. So let me actually write it out. So it's going to be var from account ID. It's going to be a type long. It's going to be equal to null. And let me actually just copy this just to save time. And we're going to do to account ID. And they're both going to be long. Now, the reason why we need these two fields is because they're going to be used for specific cases, right? We know that when we do a withdrawal, we're going to need the from account ID. Where are we trying to withdraw that money from? So that'll be utilized in those cases, right? Or in the cases of a deposit, where are we trying to deposit the money to, right? That's important. And there's a case where are we trying to send the money from and what account are we trying to send the money to, right? So there are different cases where we may need to specify the accounts, but there are cases where we may not need both of them at the same time. So, where there may be a case where we need one and not the other. So this is the reason why I'm making it nullable because of the fact that there are certain cases where these properties are being utilized. So I'm not going to define any validation because there are some cases where it may not be need to be utilized, but for sure there's going to be some validation that needs to be done on the server side to make sure that whatever account that we're trying to utilize has to be an existing account and has to be an account that's associated to the user, right? So whether it's someone trying to deposit money to an account or their own account, well, you got to make sure that it is an account that is associated to them. Or if they're trying to send money, right, you got to make sure that they're trying to send money from an account that belongs to them to another valid account. So there needs to be some validation done on the server side, but from here it can be null because there are cases where these two may not be utilized at the same time, or there may be a case where one and not the other may be utilized. So that's the logic for these two properties. And that's why there's this @JSON include, because in the cases where one or the other may be null, we can just ignore it. We don't want to display that back to the user. But if they're both actually holding a value, then we can go ahead and show that to the user. But there may be a case where there's no value in one or the other. Now, the next thing I want to create is going to require a enum, right? So I'm going to create a new folder or a new package called enum, and I'm going to create a new Kotlin class.file, and I'm going to make this an enum class, and it's going to be called transaction type, right? And just as the name implies, it's going to be a transaction type. So the cool thing about enum classes in Kotlin is that it's going to allow us to provide a constructed value just in case we want to specify the type. It's going to return the value. So I can do that here by doing val type, and it's going to be a type string. And what this is going to allow us to do is it's going to return, a type that matches that, right? So the first transaction type I want to create is deposit, and I want to define the value type, right? Because remember, we're defining constructor for it, so we can specify the type here. And I'm going to define it as deposit. And same thing for transfer. In the case that you want to transfer between accounts, you can do that. So I'm going to define the type as transfer. And then it's going to be withdraw. And the type is going to be of type withdraw. And lastly is going to be send, right? In the case you want to send money, right? You're a generous person, you want to send money or you owe money, go ahead and send that. So these are the transaction types. And now if I go back to transaction, I can utilize this enum as a field in our table, right? And how can that be done? Well, first let's actually create the property, right? It's going to be a var of transaction type, and it's going to be of type transaction type, right? Make sure to import that from the enums folder. And I'm going to give this the default value of an empty string. But what I'm going to do here is, and honestly, actually, no, I'm going to make that null in this case. Why? Because I'm also going to define a annotation here of column, and import that real quick. And I'm going to provide it rules specifically for that column. As you can see, there's a lot of rules that we can define, and you can go in and see which one piques your interest. If you go to the definition of it, or if you go to the documentation for a column from the Jakarta.persistence package, but I'm going to use the nullable property that it comes with. And I'm going to make that equal to false, right? We don't want any nullable value. So that's already going to be a rule. Yes, initially it may be null, but when we actually want to save that information to the database, it's going to go ahead and check that. If it's null, then we can't save that. And what exactly do we want to save for this transaction type? Well, we want to save the string, right? We define the string of the transaction type when we go back here and see that deposit is deposit, transfer is transfer, et cetera, et cetera. So what I can use is another annotation called enumerated. And what I'm going to define as the type for enumerated is enum type dot string. Because for the transaction type, I want to store the string of the transaction type. So whether it's the deposit, whether it's a send, whether it's a withdraw, I want to take that value of that transaction type and I want to save it to transaction type. So two things, right? We have column to make sure that this is not null. Initially, it may be null, but when it's time to save, it's going to make sure that this is not null. And what needs to be saved for transaction type? Well, it has to be the enum value, right? The string value of the transaction type. So withdraw, send, deposit, etc. And lastly, you guys already know the deal. I like to know when things occur or when any changes occur. So I'm going to define two properties, created that and updated that, and this will provide a timestamp of when things occurred, like inserting or any updates that occur with the specific transaction. So I'm going to import these two annotations for update and create, and when this instance of the transaction is being saved to the database, then it's going to go ahead and place a date timestamp to these properties. So let me go and import date from the java.util, and we should be good to go. So this is the transaction entity. You're going to need the ID amounts, the user ID that it's creating that transaction. Who does the transaction belongs to, or who's creating that transaction, whether it's sending money, depositing money, withdrawing money. Where is that money coming from, or what account is that money going to, or who is sending what money from what account to another account. There's transaction type, and we're going to take the enum string from that transaction type, from the enum that we created, right? It can be deposit, transfer, withdraw, etc. And then we have the creation timestamp. So this is a transaction. We're ready to go on to the next one. So now we got the ball rolling. I don't think I need to show another diagram. So let's go straight into the account entity. What I want to do is I want to right click on this entity folder. Go ahead and create a class, and we're going to do account for the account entity. And same thing, you guys can probably do this with your eyes closed now, but at entity, import that, at table, and we're going to provide it a name of accounts, right? Plural. So just a little explanation on what this account entity will handle, right? Obviously, we know it's going to create an accounts table, but what exactly does that mean? Well, just like any bank that handles funds, there are different accounts associated to a user. So we'll be able to create a checking or saving account, right? And if there's any other type of accounts that you want to create, then you can define that. But in this application, we'll be creating or having the ability to create a checking or savings account. Now, this is where relationships will become very important. So let me go over to a diagram so that I can go over this. So here's a little diagram to show the relationship between a user and an account, right? So from the account perspective, it's many to one, meaning I can have many accounts, but I can only be associated to one user. And then from the user perspective, I am one user, right? But I can have many accounts. So in this case, I have a checking account, I have a vacation saving account, I have an all-purpose savings account. That is many accounts, right? There are many accounts being shown here. But this account or these accounts are only associated to one user. So I'm Geo, right? I'm that single user, and these accounts belong to me. I have many accounts, but it doesn't belong to any other user, right? This is my money, right? This money, or the money in these accounts, does not belong to any other user but me. So that is where we're going to have to define for the account entity. We're going to have to establish a relationship with the user, and from the account side, we have to define that it's going to be a many to one relationship, and from the user side, it's going to be a one to many relationship, because one user can have many, but from the account perspective, there can be many accounts associated to one user. So I hope that makes sense. Let's go back to the entity and let's begin creating the properties for an account. We're going to need the usual two annotations for the primary key of @ID and the @generated value. And it's going to be var ID long is equal to null. You guys know the deal. And just in the product of time, let me just copy and paste some of the properties over. So, and it's going to have some validation already. I'm going to need the not blank and the not empty just to make sure that the user is not trying to play with me. And there's also going to be some validation already done on the DTO side, but just to make sure that, if anything ever passed through, then we have some additional security, right? There's security in depth, right? There's multi-layer security on the DTO side, and there's security done on the actual entity side. So here for name, what is the name of the account? The user has the ability to change it. So whether it's a vacation account or vacation checking account, or whether it's a multi-purpose account, the user has the ability to give a name. It just has to have a value, right? It can't be an empty string. Then the balance, right? It got to be at least 0. We don't want any negative values. There may be a case where you're a bank that does accept negative values, and if it does become negative, then you start charging or sending fees to a user. But in this case, if it ever gets to 0, then it's a problem, right? And it can't be no, of course. So if it ever is 0, or if someone's trying to make a transaction and it's already 0 and it might go under, then we'll inform the user that it's not possible. Now we're going to actually need to create another enum, and I'm going to call this account type. All right, so account type, and that's going to be an enum class. Now, like I said, there's nothing special. Account type is going to be either checking or savings. If you want to add another account type, whether it's a high yield savings or something like that, then you can do that. But in this case, it's just going to be checking and savings. And it's going to be the same concept, with the um, Kotlin enums. You can define a constructor, whether you want to give it like, a type. In this case, it's going to be of type string. So the first one's going to be checking, and it's expecting a constructor value of type. So it's going to be checking here, and it's going to be savings. And I forgot to put a comma here. So savings, so saving, singular, and it's going to be of type saving. So now we have our account type enum. We can go back into account and utilize it just like how we did before with the transaction type. So what I'm going to do here is going to use at enumerated, all right, and open that up. It's going to be enum type dot string, all right, and then add the at column, and I'm going to add the rule for this column to be, that case of if it's going to be nullable or not. I'm going to set that to false, right? This column is not going to be allowed to be false. It has to have a value. And I actually had to create the property. So let me do account type, and it's going to be of account type coming from the enum. And the default value is going to be null, but if you try to save this, then it's going to go ahead and return an error because, null is not allowed. And you guys know the rules. I want to know when this was created, when it was updated, because in this case, a person could update the name, a person could update the balance, whether it's withdrawal or deposit. So I want to know when it was created, this account was created, and I want to know when the last time it was updated. So I'm going to add some timestamps for that, some properties for that. You guys already know the deal when it comes to that. So just like how I showed the diagram when it comes to the relationship between a user and an account to a user, we got to define that relationship as a property here in this entity. So to do that, we're going to use the annotation of many to one, because from the account perspective, there can be many accounts associated to a specific user. So in this entity is going to be at many to one. We're going to need to define a join column, right? And we're going to use the at join column. An at join column annotation in JPA is used to specify the foreign key column for an entity. So a foreign key is just pointing to the association, like what is this account going to be associating itself to? And because this is a many to one, we're associating to that one, right? That one is going to be the user. And we got to define a name for this association, right? What are we going to be utilizing to associate to that specific one? Well, we're going to be utilizing the user ID, because how else will we know to associate an account to a user? We have to use the ID. I talked about how email can't be utilized because email can change, but the user ID is going to be the identifier for the user forever, right? Unless the user closes their account. But while the user is active, while the user has an account in our application, that ID will be the unique identifier that will be associated to that user, right? This account is going to be connected to that user based on their user ID. And we also want to make sure that the user actually passes a value for this, right? This can't be null, right? It has to have a value, right? There has to be some type of association between a user and an account. So is this nullable? No, it's not nullable. It has to have a value. I'm also going to use at JSON ignore, because I want to make sure that when I grab an account, I'm not trying to grab the user as well. If I don't have this at JSON ignore, it's going to attempt to retrieve the user, and I don't want that. So go ahead and ignore that. And lastly, I want to do a latent init var user. So when I create an account, it has to be associated to a user, right? And it will be initialized from there, right? I can associate the user to this account when I'm actually creating an account. So that's why I'm using latent init, because I'm pretty much informing Kotlin like this is going to be initialized. This will have a value. So we'll worry about it when we get there. But just know that when I create an account, I'm for sure going to associate it to a user. And I forgot to put name here, right? Name is equal to user ID. So that's going to be the name of this foreign key column. And now I actually have to go into the user entity because I said I'll be back because I had to make some changes. And I created the one-to-many or the many-to-one here. Sorry about that. I created the many-to-one connection here because there can be many accounts associated to one user. But from the user perspective, there can only be one user, but that one user can have many accounts. So I have to create the one-to-many relationship here. So I got to use the @one-to-many annotation, and it's going to be mapped by, it's going to be equal to user. And what this map by property is going to do is it's going to create the relationship between the account and the user, right? It's going to create a bi-directional relationship between both of them, right? Because user is just going to be pointing back to this specific user, right? That's being stored in this account. And this user is going to point back to the user that account is associated to. So it creates that bi-directional relationship between the user and the account. So to define the fact that a user can have many accounts, we can go ahead and create a field of accounts, and I'm going to make it a unique set of accounts, of type accounts, right? Because there could be many accounts or there can just be one account. And I'm going to make that initially null. Because, say for instance, the user deletes an account. Well, then the user doesn't have accounts, right? That means there's not going to be any accounts associated to this user. But when a user does create an account, then it has to have a user, right? This can't be null, right? It has to have a user that is associated to this account, has to belong to a specific user. But on the user side, there is a case where I have no accounts, right? There can be a case that there are no accounts associated to this user because the user doesn't have any accounts. So I will make that into essentially an empty set, right? This can be null. And now that association between the user and the account to user is established, that bidirectional connection is established, I just want to do one more thing from the account entity, and that's create a check at check. And I want to apply a constraint. And let me import check from Hibernate. And what I could do is I can apply this constraint or constraints. It's going to be the name. And it's really only going to be one constraint. And that is going to be that balance has to be greater than or equal to 0. That is constraint. It can't be less than, it has to be greater than or equal to 0. I know I have that min requirement of 0 for just an extra layer. I'm all about security and depth. So that's just another constraint of having a balance that is greater than or equal to 0. So at least you have two ways of validating that. So cool. We have the account entity, we have the transaction entity, we have the user entity, meaning we have 3 new tables that will be created for us based on the properties that we define in these classes, right? So, and we have established a relationship between a user and 2 accounts, right? One user can have multiple accounts, and many accounts will be associated to, or many accounts can be associated to a user. There may be a case where a user may not have an account. By default, we do create an account, but there is a case where the user may not have any accounts, which is fine. But when we do have an account, it has to be associated to a user. You can't have an account sitting in limbo. It has to be associated to a user, right? But a user can have a case where there are no accounts associated to it because the user didn't, create an account, or maybe they delete their account, right? So we're able to establish that, and then there's transaction where, whether it's withdrawal, deposits, or any other type of transaction, we'll be able to save information regarding that transaction into a table.